The diagram shows a rectangle with length x plus 4 and width x minus 1. So here's our rectangle. The length is x plus 4, the width is x minus 1. All measurements are in centimetres. Part 1, express the area of the rectangle in terms of x. Part 2, if the area is 10 centimetres squared, write an equation in x and solve it. Part 3, find the length of the rectangle in centimetres, correct to 2 decimal places. So a rectangle area is equal to length multiplied by width. This is not in the formula book. You need to know this off by heart. So the length is x plus 4 and the width is x minus 1. So underneath length, I'm writing x plus 4, and underneath width, I'm writing x minus 1. So we're going to multiply these. So we're going to break open the brackets. So we're going to have x times x minus 1, or 4 times x minus 1. So x by x is x squared. X by minus 1 is minus 1x. 4 by x is 4x, and 4 by minus 1 is minus 4. We then simplify to get x squared plus 3x minus 4. So that's equal to a, which is the area. Or you can use the box method or the array method. So it's going to be x plus 4 times x minus 1. So x times x is x squared. X times 4 is 4x. X times minus 1 is minus 1x. And 4 by minus 1 is minus 4. So we're still going to simplify, putting the 4x and the minus 1x together. And we get x squared plus 3x minus 4. So we get the same answer on both sides. So it doesn't matter which method you use. So we have expressed the area of the rectangle in terms of x. So that just means x is in our answer. So area is equal to x squared plus 3x minus 4. So area is equal to something with x in it. If we had labelled the length and the width the opposite way, we would have still got the same answer. So let's say we decided to call the width x plus 4 and the length x minus 1. So this time we would have had x minus 1 times x plus 4, the other way around. So we would have had x times x plus 4 minus 1 times x plus 4, which gives us x squared plus 4x minus 1x minus 4, which again gives us a is equal to x squared plus 3x minus 4, so the same answer. If we'd use the box or the array method, so x minus 1 times x plus 4, would have got x squared minus 1x plus 4x minus 4, which again simplifies to x squared plus 3x minus 4, so same answer. Part 2. If the area is 10 centimetres squared, write an equation in x and solve it. So that means in terms of x. So have x in your equation. So we're going to use what we worked out in part 1. In part 1, we worked out that the area is equal to x squared plus 3x minus 4. So we write down area equals x squared plus 3x minus 4, our answer to part 1. We're going to replace the word area with the number 10 because we were told in part 2 that the area is 10 centimetres. We're going to bring the 10 over the equal sign and it will change signs. So we have x squared plus 3x minus 4 minus 10 is equal to 0. We simplify. So minus 4 minus 10 is minus 14. So we have x squared plus 3x minus 14 is equal to 0. So we're trying to solve here. And normally when we are solving, if we have a linear equation, we do letters to the left, numbers to the right. But when we have a quadratic equation, we would normally say bring everything to the left and let it equal to 0. But likewise, you can bring everything to the right and let it equal to 0. It doesn't matter so long as everything is brought over to the same side and then you simplify and let it equal to 0. So if you have a squared, when you simplify, you will typically end up with an x squared and x, a constant, equal to 0. So at this stage, you can factorize and solve, or you can use the minus b formula and solve. Now, if you try to factorize this particular equation, it won't work, so you will have to use the minus b formula. So we want to solve x squared plus 3x minus 14. We put in our invisible 1. We label a, b, and c. We write out our formula. We swap all the letters for sets of brackets. We replace the a's with 1. We replace the b's with 3. and we replace the c with minus 14. So we write everything down, but instead of plus minus, we just have a plus. Stick it into the calculator, and you get approximately 2.53. And then press the back button on your calculator until you get to this plus, and just delete it and replace it with a minus, so you don't have to write the whole thing out again. And you get minus 5.5. Now this is not valid because lengths cannot be negative. So our answer is actually only going to be 2.53. So if we go back to the rectangle that was given in the question, one of the sides was x minus 1. And if we were to sub in minus 5.5, which is one of our x values down here, if we were to sub in minus 5.5 in place of that x, we would have minus 5.5 minus 1, which would give us minus 6.5 centimeters. And that doesn't make sense. You can't have a negative length. It doesn't make sense to say that the side of this rectangle is minus 6.5 centimeters. So that's why in this particular question, the solution here of x is equal to minus 5.5 is not our answer. Our only answer is 2.53. So part 3, find the length of the rectangle in centimeters corrected 2 decimal places. So we want to find the actual length now. So we were told in the question that the length is equal to x plus 4. We worked out in part 2 that x is equal to approximately 2.53. So all we have to do is write down length equals x plus 4. Replace the x with 2.53. So 2.53 plus 4 is 6.53 centimeters. So the length of the rectangle in centimeters is 6.53 centimeters, correct to 2 decimal places.